All right, this video is going to go through the assignment for simplifying radicals, just as a review on how to do this, maybe give you another perspective on it. If you enter the square root, the first thing we want to know is that when we take square roots, unless it's a perfect square, it's not an exact answer. So we should always enter an exact answer if it asks us for one. So if you put square root of 15 and you typed it into your calculator, you're going to get this long decimal. So to get an exact answer, if they say an exact answer, then this is how you would write it: square root 15, or there's a toolbar where you could just type in square root of 15. That's the exact answer. We can't simplify that. If we wanted to simplify it or give it, if it says round to do two decimal places, then we can put it in a calculator and get square root of 15, and that equals 3.87 when it's rounded to two decimal places. So this is an important thing moving forward, is when it's asking for an exact answer, give an exact answer. If you put it in as a decimal, it won't, we'll mark it wrong, saying, no, that's not it. So let's practice simplifying these. Now, if it's not an integer value, or simplify it if it is an integer value. If it's not a real number, enter none. When we talk about real numbers, like if we have a negative underneath the square root, we can't take a negative square root and get a real number, because there's no number multiplied by itself that gives you a negative number. Because negative 11 times a negative 11 is always going to equal to positive 121. Positive 11 times positive 11 equals positive 121. So if it has to be the same number, you can't say, well, negative 11 times a positive 11. Those are two different numbers. That's not one integer value. So if the negative is underneath the square root sign, then you'd enter none. If it's outside, we can do this. So 121 is equal to 11 times 11. And so when we take the square root, it's finding a pair underneath that are the same. So every pair that's underneath, one will come out. So this would be just a negative 11. 196, you could put this in your calculator and figure this out, or you could say, well, 196 is equal to, I could just do the divided by 2, so I'd have 196 is 2 times 98, that's 2 times 49, and then once I get to 49, I'm like, oh, well, that's 7 times 7. We can recognize that. And the same thing applies for every pair. This would be all underneath the radical, then 1 comes out. So I have one pair of twos and one pair of 7, so 2 times 7 is equal to 14. So the square root of 196 is 14. Try these two on your own, and then come back and check if you want to see if you got it right. Pause the video. All right, if you did this on a calculator, if you worked it out using a factor tree, either way, the first one you should get negative 16, because the negative is outside of the square root, and then 10. Square root of 100 is 10. So what happens if it's not just a perfect square? Like none of these are just perfect squares. So we want to simplify them so it contains at most one radical term that does not contain any perfect squares. So basically what we're trying to do is we're going to try to take this number and we're going to break it down and try to get any perfect squares out. So if I look at this, I know 80 is 4 times 20, because 4 is, I'm looking for perfect squares. So 4 goes into 80 perfectly. And then 20 can also be divided by 4. That's 4 times 5. Now I have a pair of 4s. They're both perfect squares, so I could say 2 times 2 and 2 times 2, so I'd have 2 pairs of 2s. It's the same thing. And so I would be left with 4, and then the square root of 5 has to stay underneath, because there is nothing that I can simplify 5, a perfect square that goes into 5. Another way is you might see this and you might say, well, 16 times 5. If you get to this point, you can say, well, the square root of 16 times the square root of 5. Square root of 16 is 4 times the square root of 5. So there's more than one way to break it down. The goal is you're trying to get perfect squares and get anything that's a perfect square out. Even if you went as far as, if we did 80 and we did, well, that's 2 times 40, 2 times 20, 2 times 10, 2 times 5. We have one pair, 2 pairs. So we'd have 2 times 2, square root of 5, which is equal to 4 times the square root of 5. So no matter how you look at it, you can break it all the way down, or if you can just look at that and say, oh, I know 16 is a perfect square and goes into 80, and the square root of 16 is 4, you're going to get the same answer. So, and you can always, check with your calculator, but it's helpful to do it this way so you can be certain that we're not rounding anything, we're not putting decimals in, we're getting a perfect square. So 99. Well, the only two numbers I can think that multiply 99 are 9 times 11, and 9 happens to be a perfect square. So this would be the square root of 9 times the square root of 11. Square root of 9 is 3. Square root of 11 just stays underneath. So it's 3 times the square root of 11. 245. So on this one, I'm like, I'm not sure, but I know 5 goes into it. So I'm going to try 5 first. So it doesn't have to, like I said, we don't have to know exactly. And I see that's 5 times 49. Well, that was handy because square root of 5 times the square root of 49, we know the square root of 49 is 7. So that's 7 times the square root of 5. Now you always want to put the non-radical term first and then the radical term second. One thing that might be helpful on this, and let me just scroll down here a little bit and maybe right up here, okay, is make a list of the perfect squares. So if you wanted to print out a list, like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49. And you can just, if you don't know these on the top of your head, multiply them, use your calculator. What is 6 squared? What is 7 squared? 8 squared, 9 squared is 81, 10 squared is 100, 11 squared equals 121, 12 squared equals 144. Usually you're going to be okay if you know up through 1 through 12 squared. If you can recognize these numbers, when I talk about the perfect squares, I'm talking about 1 is a perfect square, 4 is a perfect square because it is the square root of 4 equals 2. So it goes both ways. So you recognize those numbers. It will help you when you're getting to this point where you can simplify them. So when you come to 5 times 49, you'll immediately recognize, oh, 49 is a perfect square. All right, now when we're solving equations, and this is a little preview because you're actually going to be doing this in the next lesson as well, but it's really basically the same. When you're trying to solve a quadratic equation, you're going to be taking the square root of both sides. That's this to solve. So if we take the square root of x squared, then we get x is equal to, and what's the square root of 64 is equal to 8 or a negative 8, because we can have a positive or a negative that multiply to get 64. So the key is to get the squared variable alone, then take the square root and consider the positive and the negative solution. So in this case, I've got 2 times x squared. So what's the first thing I have to do? I have to get rid of that 2. So I'm going to divide by 2. So we've got x squared equals 9. And now when I take the square root of both sides, I can get a positive 9 or a negative 9. Nope, that's not true. I can get a positive 3 or a negative 3. Because that's what the square root of 9 is. 3 times 3 is 9. All right, if you're solving an equation, we're just trying to get the x alone. So if I have a whole something in parentheses, I can take the square root of both sides of that, and I'm going to get x plus 5 equals a positive 7. And I've got to consider x plus 5 equals a negative 7. And so when I solve that, we subtract 5 from both sides. So I either get x equals a positive 2. If I subtract both sides from this one, x equals a negative 12. So in this case, I could get positive 2 or negative 12. The other thing you can always do is check your work. If I put 2 in here, 2 plus 5 is 7. 7 squared equals 49. That checks out. If I put a negative 12 in here, negative 12 plus 5 equals a negative 7. But when you square a negative 7, you're going to get a positive 49. So that checks out as well. Finally, when we have adding and subtracting, we've got to get anything added over to the other side. We want that x term alone. So we're going to have x squared equals a positive 20. Now if I take the square root of both sides, 20 is not a perfect square. So one way we look at this is we say plus or minus 20. However, can 20 be simplified? Are there any perfect squares that go into 20? Well, I know 20 equals 4 times 5, and 4 is a perfect square. So the square root of 4 times the square root of 5 equals 2 times the square root of 5. So this would be a positive 2 times the square root of 5, negative 2 times the square root of 5. And that would be your answer. So hopefully that helps you with those simplifying radicals. Let me know if you have other questions.